Hey guys, Beacon here. In this problem, you're given an array. For each of the n-2 inner elements, you have to go through them sequentially, and for each element, you have to either add its value to the previous element and subtract its value from the next element, or remove its value from the previous element and add its value to the next element. After doing this for all n-2 elements in order, we have to determine how many different arrays we can end up with at the end. For this problem, we have to realize that after we do an operation on an element, we will never change the previous element again. This means that, as long as the current element we are on is not 0, we'll end up with two different arrays. The array where we chose to subtract from the previous element, and the one where we chose to add. Nothing we do in the future will make these two the same again, because the previous element differs, and we never change the previous element again. Realize, however, that when you're on an element that is 0, we will just end up with two of the same arrays, because adding 0 and minusing 0 is the same thing. So it will only create one new array. It is quite simple to realize now what the answer is. We start with one array, the original array, and afterwards, at each of the n-2 elements we have to operate on, we multiply the current number of arrays we have by 2, and then just remove the duplicates. We can keep on doing this process to get the answer. Realize now that the only hard part that is left is to figure out how many duplicates there are at each step. This is where we can use the thing that everyone loves the most, dynamic programming. Let's create a 2D array dp pos val, so position and value. This means that at dpij, it will tell us how many different ways there are to make position I equal to the number j. For example, dp47 equals 5 tells us that there are 5 different possible sequences of operations that we can do to end up with the number 7 in position 4. We can then create this recurrence relation where dpi ri plus j is increased by dpi minus 1j, and dpi ri minus j is increased by dpi minus 1j. This means that either we can add the value of the previous element to the next term, or we can subtract the value of the previous element from the current element. When implementing this, however, you should be careful not to add plus 0 and minus 0 two times, because it will be counting the same thing twice, because the two arrays formed is actually the same array, because plusing 0 and minusing 0 is the same thing. You might be wondering, hey, array indices are non-negative, how do we store negative values in the dp array? Because, of course, if you minus 5 from 2, it will be negative 3, so we have to store negative values. Well, how you do this is you have to create some value. You have to find some value between the smallest and largest possible values to be 0. For example, when I solved this problem, I set 100,000 to be 0. Then a number like 110,000 would be 10,000, and 90,000 would be negative 10,000. And while looping through doing the dynamic programming, just store how many possible sequences of operations there are to get 0 at each element, or dpi and then the value you chose to be 0, for example, 100,000. After we do this, we can loop over the n-2 inner elements and multiply by 2 and remove the duplicates as we go along. And this is how to solve this problem. I hope you enjoyed the solution and stay tuned for more interesting and cool problems.